Like I said, we're going to be solving these. And for some of these, we're going to be able to just solve right away because we already know how to solve them. For others of them, we're not going to be given the factor like we were given last week. Instead, it's going to be our job to find the factor that will work out. So roots and zeros, when we say we have a root of a function or a zero of a function, it's really saying the same exact thing. It's telling us that we found a factor of it. And that's where one of the x-intercepts is. So if you ever hear, oh, we found the root of a function, that's a solution to the function that works. So it's one of your x-intercepts. Okay, so what we're going to do is we're just going to start off with problems that we should be able to solve already. We're going to solve them, and then based off the solutions, we're going to state the number and the types of roots. Okay, but we should be able to solve these 4 problems that we have up here already. And we'll start off with a really tough one. X plus 3 equals 0. This is not a trick question. What does x have to equal? Negative 3. Okay. So for this first one, x equals negative 3. Now, when this says state the number and types of roots, that means how many answers did we have? And then not only how many answers we have, is it real or imaginary? So how many answers do we have here? We have one answer. Is it a real number or an imaginary? It's a real number, so we'd say 1 real root. Okay. Number 2. X squared minus 8x plus 16 is equal to 0. How can we solve this one?
You have to take the 16 to the other side?
We don't have to take the 16 to the other side. Yeah, we can factor it. Okay, how can we factor this? Yep, negative 4, negative 4. So x minus 4 times x minus 4 is equal to 0. So what does your x have to equal? 4. Now, careful here. How many solutions do we have? We actually have 2 solutions. Why is this 2 solutions? I only see one answer up here.
Do you have to have 2 4s?
Yeah, there's really 2 4s here because both of these are equal to 0. So there's actually 2 solutions. So we actually have 2 real roots. Because there were two things here that both gave us x equals 4.
So then which one is the answer, like the thing that you would circle?
Number 3, x cubed plus 2x is equal to 0. How can we solve this one? U substitution really wouldn't work out here because this is a cube. No. Can we just take an x out? Okay, good idea. Take an x out. What do we have? X squared plus 2 is equal to 0. Okay, so if we have x times x squared plus 2 equals 0, this first x gives us one of our solutions. So that tells us x should equal 0. The second part here says x squared plus 2 should equal 0. Well, if x squared plus 2 should equal 0, what does x squared have to equal? Negative 2. So then what is, if x squared is negative 2, what are the solutions you get? Plus or minus I square root of 2. So here are our solutions, 0 and plus or minus I squared root of 2. So what are the numbers and the types of roots? So yeah, so here we have one real root for the 0. And how many do we have for the imaginary?
Oh,
We have 2 because there's a plus and a minus. Is that okay? Okay, we're going to do one last one. X to the 4th minus 1 is equal to 0. We have a plus and a minus, so that means that we have 2 imaginary solutions there. All right, number 4, x to the 4th minus 1 is equal to 0. How could we solve this? We could use u substitution, but there's an easier way. What can we do?
oh. Yeah, the one on the
Okay, we could add 1 and then take the square root of both sides. We wouldn't want to do the 4th root, but we could do that. So if we add 1, we have x to the 4th is equal to 1. And then if we take the square root of both sides, if we take the square root of both sides, we have x squared then is equal to what 2 values?
plus or minus
X.
1.
Yep, so x squared is 1 and x squared is negative 1. Then what would we have to do with both those x squareds? Take the square root. Okay, so if x squared is 1, the square root of 1 gives you plus or minus 1. What's the square root of negative 1 give you? Yep, plus or minus I. So what are the numbers and types of roots here? Yep, 2 real and 2 imaginary. Okay, now what I want us to now look at is the number of roots we ended up having and then the highest exponent of the polynomial, or the degree of the polynomial.
Why are you still square-rooting it after you simplify the x?
Why did we square root it a second time? So here if we take the square root of x to the 4th, we only have an x squared. That's not x yet, so we have to take the square root again to get x. If you 4th root it, you are neglecting 2 of your solutions. So the other way to do this would be to factor it out to x squared minus 1 times x squared plus 1, and then go to that step. That also would work. All right, so look at the total number of roots we have here and the degrees of the functions, and what do you notice? So for this first problem, what's the degree of this function? It's a 1, and how many total roots did we have? We had 1. Degree of the second function? 2, and we had 2 real roots. Degree of the third function? 3, and how many total roots did we have? We had 3 because we had 1 real and 2 imaginary. And the last one had a degree of 4, and we had a total of 4. It's always going to do that. So when we are solving these, that's one way that's going to help us solve is we're going to look at what the highest exponent is, and that tells us how many solutions we should have. Now, sometimes, like in our second example, we will have 2 real roots, but they will end up being the same exact number. Okay, that will happen once in a while. But we still have 2 of them hidden in there with that 1 number. Now, if there was a way for us to figure out if we had real answers or imaginary answers, that would be helpful to us. And furthermore, if there was a way for us to figure out if our numbers should be positive or negative, that would also be helpful. That way we're not just trying random numbers. We could have a way to kind of whittle down our field. These ones worked well because they all factored. That's not going to always be the case. So, there's pretty smart guy named Descartes, and he came up with a rule of signs. And the rule of signs is a way to tell us how many positive answers we can have and how many negative real answers we can have. Okay, so we have p of x is a polynomial with real coefficients. Okay, and here we have to make sure that we're arranged in descending order. So what does that mean?
Like exponent and an x3.
Yep, highest exponent to lowest. All right, if we're not arranged in descending order, this won't work. Okay, so we have to be in descending order. Then we look at two different cases. And we're just going to look at how many times the signs change in front of the coefficients. So if we go from a positive to a minus, that's a sign change. If we stay positives throughout, that's not a sign change. So what we're going to look at here, the first thing tells us the number of positive real zeros of this function p of x. The number of positive real zeros is the same as the number of sign changes in the coefficients. So if we look at how many times the sign change, so if you go from a positive to a negative, that's a sign change. That would be 1. If it changes back to a positive, that would then be 2. So you're going to count how many times the sign changes, and that's how many positive answers we could have. Or it's less than that number by an even number. So multiples of 2. So if you count your sign changes and you get 4 sign changes, you could have 4 positive numbers, 2 positive numbers, or no positive numbers. You just keep decreasing by 2 until you can't anymore. If you count your sign changes and get 3, you could have 3 or 1. If we decrease 1 by 2, though, we're now in the negative, so it doesn't make sense anymore. Once when we try it, it'll make a little bit more sense. And then the number of, I should say negative, the number of negative real zeros of p of x is the same number of sign changes, and this time it's of the coefficients of p of negative x, or less than this by an even number. So if we were to substitute in a negative value for every x, that will end up changing the signs for some of them. And so then we're going to count those sign changes, and that would tell us how many negative real zeros we have. So for example, let's say whoa, I don't know what happened there.
Those things are kind of crazy, right?
I was pushing the button on accident. All right. So let's say we have this function. P of x is equal to x to the 4th plus 3x cubed minus 2x squared plus x minus 1. The only thing we care about here are the pluses and the minuses in front of every single coefficient. Okay, only thing we care about. So if we want to find out how many positive real zeros we have, we want to count how many times our sign changes. So we start off at the left. This is currently a positive number, right? And it stays positive. So did it change there? No. Okay. Now it's positive and it changes to a negative. So there it changed once. So that's 1 time. Negative, did it to a positive, that's a change. So it changed another time. Positive to a negative, that changed a 3rd time. So here, how many times did our sign end up changing? 3. So we would have 3, and then we decrease that by an even number, so by 2. So 3 minus 2 is 1. So we would have 3 or 1 positive answers.
So if it would have started out negative x4, then that would have been another.
That would have been another sign change. Okay? Now, this p of negative x let's just think about what that affects in our equations. If you plug a negative x in for your x values in there, these are all being raised to an exponent, so we have to think about what that exponent does. So if you take a negative number and raise it to something like the fourth power or the second power, an even power. So a negative number to an even power, what does that do to the negative? It makes it a positive, okay? So if I take this negative x and put it here in the fourth power or into the second power, will that affect the signs in front of those two? It shouldn't. No, it won't. Because when you take a negative 1 and square it, you get a positive 1 back. So it's not going to affect the signs in front of there. Now, what happens if you take a negative value and cube it? It's negative. So it will affect the x cubed. It would make this a negative sign. And it would make your x a negative sign. So what you're going to do to find p of negative x is you're going to go through and you're going to write what signs it would be. So x to the fourth, it's not going to change at all, so that's going to be positive. X to the cubed, if you put a negative number in there, it would get negative. So this positive now changes to a negative. X squared, it's not going to affect it, so that's going to stay negative. X would change to a negative, so that sign changes to a negative. And negative 1 would have no effect, so we're going to leave that negative. Yep. That's just part of the definition. You just, whatever number you get for the sign changes, you just always subtract 2 from it. Every time.
What if there's only 2 signs?
What's 2 minus 2?
Oh, well,
0.
What if there's negative? Can you have negatives?
No, you can't. That doesn't make sense, does it?
No.
Okay. So are we okay with these new signs up here? Yes? No? So which signs do you end up changing? You change any signs that have exponents to what types of powers? The odd powers. Anything that has an odd power, you have to change the sign in front of it. The even powers, you just leave the same. So x to the fourth, we left positive. X cubed, we changed it from a positive to a negative. X squared, we left it negative. X, we changed it from the positive to the negative. And then the minus 1, we left as a minus 1. So now look at the new signs that you wrote up here. How many times did it change? Only one time. It changed from being positive to negative here, and then it stayed negative the rest of the way. So there it changed one time. Can you take 1 minus 2 and get? No. Then we get negative solutions, which doesn't make sense. So here we would have 1 negative. Okay, so let's try this with another one. We're going to state the number of positive real zeros, negative real zeros, and then imaginary, and I'll help you find the imaginary after. So this is p of x is equal to x to the fifth minus 6x to the fourth minus 3x cubed plus 7x squared minus 8x plus 1. So it starts off as an x to the fifth. So p of x is equal to x to the fifth minus 6x to the fourth minus 3x cubed plus 7x squared minus 8x plus 1. So first we're going to look at just that p of x function and count the sign changes. So currently a positive. Does it change? Yeah. Okay, so there's 1. Does it change going to the third power? No, so we're still just at 1 sign change. Does it change going to the second power? Yeah, so it's 2 sign changes. Does it change going to the first power? So 3, and does it change going to the plus 1? Yeah, so how many total sign changes did we have there? 4. So 4, if we subtract 2 from 4, what do we get? 2, can we subtract 2 again? Yep, so we have 4, 2, or 0, positive. Those are our possibilities. We could have 4 positive answers, we could have 2 positive answers, or we could have 0.
So it's like 8. I still just keep
If it was 8, then we'd have 8, 6, 4, 2, or 0. Okay, so now let's go through and figure out the negatives. So which sign changes, which signs will end up changing here? The odds. So x to the 5th, what will be this new? It'll be a negative. What will x to the 4th be? Negative. It stays negative. X cubed will be, end up being positive. It would change. X squared, positive.
That looks like it's 3x squared. No.
That's a cube. Just a little blurry for some reason. The negative 8x would change positive, and the plus 1 would stay positive. So with these new sign changes here, how many times did we change? We changed once. We just changed right here from a negative to a positive. So that means we have 1 negative. How did we what?
How'd you only change once because you need that negative?
You count, looking at the new signs, you count how many times the sign changed. You don't count how many times you've changed it. Okay. Yes. What? That's what we're doing right now. Here we've determined the number of possible real zeros, the possible negative, and now we're going to find the possible imaginary. So now, what does the highest exponent tell us? Our highest exponent should tell us how many total answers we have here, right? Here the highest exponent is a 5. So, we definitely have 1 negative answer here. We could have 4, 2, or 0 positive answers. That means depending on the combination, we might end up getting some imaginary numbers. Right? So if we have 4 positive answers and 1 negative answer, how many total answers did we get? 5. So would we have any imaginary then? No. So that would be a 0 for the imaginary. What if we only had 2 of the positive answers, though? So if we had 2 positive answers and 1 negative answer, we would need to have 2 imaginaries to get a total of 5 answers. Okay? And the last one, we could have 0 positive. So if we didn't have any positive answers and only 1 negative, how many total answers would we have to have? We'd have to have 4 to get the imaginary. So this would be our number of possible positive, negative, and imaginary answers. And the imaginary you find out by figuring out how many more you would need to get the highest exponent when you've made all the combinations. Yeah. Is that okay? Okay, so now we're going to take this information and we're going to have this help us solve these equations. So once again, we're not given the factor that works here. We have to find it ourselves. So this information will help us because here, if we see that we definitely have 1 negative answer, those would be the types of numbers we would want to try first, would be negative solutions. So we're going to find all the zeros for each function. So here we have f of x is equal to x cubed minus 4x squared plus 6x minus 4. Now, if you ever get a function here that you can see you can factor by grouping or some other type of factoring that we've already talked about, solve it that way. Okay? It's going to be a lot quicker. So if you see that you can do that, solve it like that. All right? But in this case, that's not going to work. Yeah, grouping is where you put the 2 in parentheses. And that won't work here because notice our 2 numbers here don't line up. Like our first 2 numbers are 1 and 4, and our last 2 are 6 and 4. So those won't ever be the same.
So if it's 1 and 4 and 1 and 4?
If it was 1 and 4 and 1 and 4, then it would work. Yeah. Okay, so what we're going to do when we want to find all the zeros, is first we want to decide what type of numbers we want to look for. So do we want to look for positive answers or negative answers? So we're going to count the sign changes. Okay. So how many sign changes do we have in this function the way it is? We have 1, 2, 3. So that means we have 3. Or what else could we have? Okay, so we have 3 or 1 positive. We want to do the same thing now, thinking about the possible negative solutions we could have. Okay? So just right above, I'll write what your new signs would have to be here. So x cubed would have to change to negative x squared would stay negative. 6x would have to be a negative, and negative 4 would stay negative. So how many sign changes? 0. So we would have 0, negative. Okay. Now, how this helps us. When we're looking for solutions, would it make sense for us to try negative answers here? No. If we try negative answers, we're never going to find one because they're not going to work. Okay, so we're only going to try positive numbers. Now, we also don't want to just try random positive numbers. Okay? That wouldn't make much sense. We want to think about this logically. So our last number here is negative 4. Okay? Think about when you factor. If you have 2 factors here, how do you always get the last number? It's the multiplication of the last 2 numbers, right? So when we're trying to break this down and find the solutions, one of our solutions should be some sort of factor of 4. Okay? So we're just going to try the factors of 4. So what are our factors of 4?
2.
Yep. So we're just going to try 1, 2, and 4. And hopefully one of these will work out right away for us, and then we'll have our solution. So to do this, we'll set up synthetic. And I'm going to show you a way to set up synthetic so it doesn't take up 2 lines every time. Okay? So our coefficients are 1, negative 4, 6, and negative 4. You can set up synthetic division so it takes up the few lines every time if you want to. Otherwise, here's your other option. You just put the bar right underneath your coefficients. A line down your last column. This is going to represent where your remainders are. A line out in front of the 1 is going to represent the number to the left of that will represent what you're multiplying everything by, or what you're trying to divide, what the factor is. And you just do the middle step in your head. So here if we try 1 first. Okay, calculators will become your friend on this so that you don't make silly math mistakes. Okay. So when we do synthetic division, what do we do first? Drop the 1 down. So we're going to drop the 1 down. Then what do you do with this 1? Okay, so 1 times 1 is 1. And then we would normally write it underneath here and add it, right? But we're just going to do that step in our head. So we're going to have 1 plus negative 4. Negative 3, yep. And then what do we do with that? Okay, so we multiply negative 3 by 1 and we get negative 3. Then once again, we're going to do this step in our head. 6 plus negative 3? 3. 3 times 1? 3. When we add that to negative 4, what do we get? Yeah. You get negative 1. So did that give us a solution? No. Okay, so then let's try 2. We're looking for a 0 over here because that tells us it's a solution. Okay? So now we'll go ahead and we'll try the 2. All right, so once again, now this time we'll take 1 times 2. 1 times 2 is 2. We want to add that to our negative 4. We get negative 2. Now we have to take 2 times negative 2. We get negative 4. We want to add that to our 6. 2. 2 times 2. Positive 4. We want to add that to our negative 4, and we get 0. So what does that tell us about 2? It works. That's one of our solutions. So one of our solutions over here is 2. Okay? Now, with our resulting equation, it's a quadratic. We have x squared minus 2x plus 2 left. We could try to factor it. Should see pretty quickly, though, that this is not factorable. So what's your other option that you can do to solve quadratics? You can do completing the square, the quadratic formula. Okay, quadratic formula will probably be a little bit quicker for these, unless you got super fast at completing the square. So x equals negative b, right? So we'll do the quadratic formula. So x equals negative b, so what would that be? 2 plus or minus the square root of b squared. 2 squared is 4 minus 4ac. So 4 times 1 times 2, 8, all over 2a. 2a is 2.
What's the A?
A is your x. What's attached to your x squared? Yep. So 4 minus 8 gives you negative 4. Okay, so we have 2 plus or minus. What's the square root of negative 4? 2i all over 2. And can we simplify that down? Yep, well, will that simplify down too? Yep, 1 plus or minus I.
Where did you get the x squared minus 2x plus 2?
Oh, right here. For synthetic division, we always start with the one exponent lower.
How did you get the 1 plus or minus I? Plus or minus 2I?
No, it's just 1 plus or minus I, because remember you can only cancel things that are being multiplied. So this would be like taking a 2 out of the numerator and over 2, and then your 2's can cancel. Is that okay? We'll do one more together. Let's see. They're both the same, pretty much. So let's do this one. It's fine. All right, so number 7. F of x is equal to x cubed minus 3x squared plus 9x plus 13. Okay, so first we want to decide what numbers we even want to try. Not always, but a lot of them will be. Right, so we can do the quadratic formula. If it's not cubed, you would have to try to find another solution afterwards. And we'll do one of those tomorrow. So how many sign changes do we have here? There's 1, and then there's 2. Stayed the same. So 2 or 0 positive. Okay. So now let's go through and let's write down what the new signs would be so we can find the negative solutions. So what does the first sign end up being here? Negative. The x squared would stay negative. The 9x would be negative, and then plus 13.
Wait, why does that say positive?
So there's no x here. It's plus 13 would just be, yep, stay the same. So how many sign changes do we have with our new signs? 1. So here we have 1 negative. Okay, so now in this case, what are we going to look for? Are we going to look for a positive answers or negative answers? Which one? Probably the negative here. Why would we go for negative instead of positive? Yeah, there's definitely one negative answer. Is there a possibility that we have no positives? Yeah. And so we could be trying solutions here that just won't ever work. So what numbers do we want to try here? Yeah, we're going to try 1 and 13 because those are our factors of 13. Now, because we're going to look for negative, we're just going to make them both negative when we try. Okay? So synthetic division, what should our coefficients be written out here? Positive 9 and 13. We did change the sign, but those are only used to determine how many negative solutions we could have. Whenever you're setting up synthetic division, you always want to use the signs of the original function. Okay, which one do you want to try first here, negative 1 or negative 13? Yeah, I'd probably try negative 1 here too, because if you put negative 13 over here, that means you're multiplying everything by negative 13. Could you see our numbers getting very large if we did that? So negative 1 will most likely work. So what should we do first? Drop the 1. Okay, 1 times negative 1? Negative 1, and then we have to add it to our negative 3. So we have negative 4. Negative 4 times negative 1. It's a positive 4 added to our 9. 13. 13 times negative 1. Negative 13 added to our positive 13 is 0. So what's one of our solutions? Negative 1 is one of our solutions. Okay, what's the quadratic we have left?
1x squared minus 4x plus 13.
Yep, x squared minus 4x plus 13. That's definitely not factorable. So we'll use the quadratic formula. So x equals negative b. So what would we start off with here?
Negative 4.
Positive 4, yep, plus or minus the square root.
Negative b squared.
So b squared would be 4 squared is 16 minus 4ac. So 4 times 1 times 13. 52, yep. All over 2a. 2a would be 2. All right, 16 minus 52. Yep, negative 36. So that means we really have 4 plus or minus. What's the square root of negative 36? 6i. Negative because it's, or I because it was negative. And then all over 2. Can that be simplified? Yep, to 2 plus or minus 3i. So there are our solutions. We'll stop there, mostly because we're almost out of time.